Hey everyone, today we're going to be going over an example on how to draw polar curves. And for today we're going to be going over this specific example. Draw the polar curve r is equals to 1 plus sine theta for the range theta moving from 0 to 2 pi. And before we start, I would like to go over the steps that you need to follow before you start drawing. So the point of this procedure is to avoid drawing any tables and wasting over 10 minutes just doing a simple questions like this. So the goal is to do this question in just under 5 minutes. So if we follow the steps 1, 2, and 3, we should be able to do this question in a record perhaps 5 minutes, because it's such an easy example, and I feel like a lot of people tend to overthink drawing polar curves, and it's such a simple and fun exercise. I hope everyone's going to enjoy this. So the steps are as follows. First, we have to let r is equals to y, where y is going to be a function of x, and then theta is going to be equals to x, so that we can draw this polar function in the xy plane as y as a function of x. And the second part we're gonna have to notice how y of x changes as x changes, because this is gonna tell us how theta changes as r theta changes in the polar region or polar curve. So, and the third step is we have to translate this change into the polar plane, and that should be easy enough after we've done step 2, or maybe we'll do step 2 and 3 roughly interchangeably as we go along. So let's quickly jump into the solution. Okay, so following that step, I'm just going to be lettering my solution step by step using the above steps. I hope that's going to be understandable. So the first part we've been given, I'm just going to write again here the polar curve equation. It's r is equals to 1 plus sine theta. Okay, so first we let r equals to y of x, and then we let theta equals to x, so that we have y of x. Therefore y of x is equals to 1 plus sine of x. And I hope this is easy enough to draw. If you are doing polar curves, I think you should be qualified enough at this point to be able to draw y is equals to 1 plus sine of x. And if you're still struggling, that's not a problem as well. With a little bit more practice, I think anyone can be able to draw even the most difficult of trig functions on the y-x plane and eventually on the polar region. So I'm just going to quickly draw it in green. So the one here tells us that we're going to be having a toggling axis at 1. So I'm just going to draw it as a dotted line. I think that's going to help us, give us some sort of direction. And then this means that our maximum is going to be at 2 and our minimum is going to be at 0. And this is our x-axis again, and that's our y-axis. So I'm just going to quickly draw it. Our sine is going to start at 1 and it's going to have a maximum at 2, move back to 0, and then start back at 1 again. And that should be our range, because we did specify that the range down here is going to be from 0 to 2 pi for theta. And remember, we said theta is equals to x now, so that means x as well must be from 0 to 2 pi. So you can pause here if you want to understand how I drew that function. I think I should place labels as well here. I'm just going to quickly label this. This is going to be at pi over 2. That's going to be at pi, and that's going to be at 3 pi over 2, and that's going to be at 2 pi. You don't have to use radians as your units here on the x-axis, depending on what syllabus you follow. Yeah, but for my specific example, I'm going to be using radians here. You could be using degrees if you like. It doesn't change anything, as long as if you're going to apply it to a calculator, you remember which one you're using, radians or degrees. Okay, so now we have this here. So now we're going to do step number 2, we want to notice the relationship of these two, of what's happening here as it changes. So to do that, what we have to do is we have to break down our x-axis into the quadrants that are going to be appearing on the polar axis. So I'm just going to quickly draw the polar axis here, and this can be seen as probably step 2, if you will. Just going to carefully draw it, and it's going to have 0 there, and we're going to have pi over 2. We're gonna get pi, 3 pi over 2, and well, this is basically 2 pi as well. Okay, so, and now we can continue. So what we're gonna do is we're gonna break it down. So from 0 to pi over 2 is 1 quadrant, and I want to show it here on our xy plane. So I'm just gonna draw another dotted line. I hope no one is getting tired of the dotted lines already. And next we're going to draw the quadrant here, which is from pi over 2 to pi. So we're just going to have it here. So this is all going to help us be able to understand how to draw this function from the xy axis to the r theta axis. It's not really axis, it's the polar plane. And okay, so now we're gonna draw the third quadrant. We're gonna just partition it, so this one here matches this one here, and lastly we wanna draw this one here, which is gonna be that. So I think I can switch over to a red pen. What's important here is recognizing how r changes over time, and in this case our r is y here and our theta is x. Notice that our theta here is just how this changes over time. This is basically our theta. So as we move here anti-clockwise, we are increasing theta, and r, you can see it as you can treat it as sort of a vector length in the polar region. That's r. So if it's length, it means that r is always positive, and this is a very important one. It might not come necessarily important here, might not prove to be important here, but it's very important when you sketch curves where y tends to be negative. For this one, I don't think it's going to be negative. No, it will not be negative. The lowest point of y is at 0, so it won't be negative, but you must remember that y and r must always be positive or 0 at worst. Okay, so let's start sketching this. So what I'm going to do is I'm going to turn this curve into a red one so that it's more visible and more distinguished. Okay, so we're going to start on the first quadrant here. We want to see how r changes as theta changes from 0 to pi over 2, and theta is our angle, please remember that. Okay, so let's focus here on our xy axis. So at x is equals to 0, so you can treat x as theta if that helps you. I'm just gonna write it here as theta, and then you can treat y as r. That's gonna make life easier. Okay, so from theta is equals to 0, r is already starting at 1, so we can come here and we're gonna break our axis down. We're gonna just label it 1, 2, and 3, and we're gonna do so. I think we should have done this at the start. It would have made life so much easier, and that's gonna do that. Okay, so at theta is equals to 0, r is already 1. That means we're gonna be starting somewhere here. I'm gonna use black now. I have to change. Okay, so r is gonna start there at 1, and then it moves all the way from 1 to 2, and that's at pi over 2. That means at pi over 2 we expect it to be at 2 of up there, and this is very important because it means that it's going to change over time. But notice that our trig function doesn't change in a straight line. this is a sort of curvature, so if you want to draw it like that, you're going to have to apply the necessary curvature as well. So it's going to look something like that. And then just like that, we've done the first quadrant. We can tick it off. Okay, and now let's focus on pi over 2 to pi. This is going to be this quadrant. So at pi over 2, we're at r is equals to 2. And then at pi, I'm going to have to draw more labels here. 1, 2, I think we don't even need 3, but just so it looks good. 1 and 2. I think we're going to need 2. And we're going to go to back to black. Okay. I'm just going to let that auto-save. I don't know why. At pi over 2, it's at 2. R is equals to 2. But then at pi, it goes back to 1. And this is important, so we want it to stop there. So I'm just going to draw it. Again, it looks like it's just going to be symmetric to this one, because it's also curved. It's not a straight line. I cannot just draw a straight line down there. It has to curve just as our XY curve curves. So let's try to make a bit of a curve, and I'll try to make it equals to the other one. Sort of equal. Yeah, I think I get the idea. I hope you get the idea. Okay, so from that, we've successfully drawn the curve for the first and second quadrant. Let me see if I can change that, make it look a bit more better, a bit more bulgier. Okay, I think I overdid that. Okay, if you're starting to get the hint, you can pause the video here and do that part yourself and do the rest of it, and we're gonna see if you're right or not. Hopefully you should be right. This is very simple stuff. I think anyone can do it after a few exercises, and it should start to be even more enjoyable. Okay, so the second part, we're just gonna, this is pi, and this is okay, this is gonna be from pi to 3 pi over 2, so it's gonna be the third quadrant. It moves, r moves from 1 to 0 as we move across pi to pi over 2. So it's gonna stop there because that's where r is equals to 0. So again, because it's a curve, you cannot just draw a straight line from 1 to 0. We have to make sure to curve it a bit, and it's gonna look something like that. Okay, and then we can tick this part off because we've just done it. And then for the last quadrant, this one here, with 3 pi over 2 to 2 pi, it moves from 0. R moves from 0 to 1, and again it's curved, so we expect it from 0 to reach 1 there where we started our curve. So again, it should be curved, and just like that, we're done. So it took a bit longer than 5 minutes. That's because I was doing all the explaining, but I think when you start doing it by yourself, you should find this a bit more easier. I'm gonna end the video here. Thanks, guys.